Pleasure.
Round of applause, please.
Okay. Okay, thank you for the introduction. My intention is to be as short as possible because I think the most important is what we will have after, just in the round table, to discuss different topics. I don't think if I do this, the presentation will start or not. Yes. So the company that we saw previously, it was a big company. So sometimes when we talk about 3D printing and all the new technologies, we understand that only the big companies can adopt these technologies. And I want to just break through and say that this is not true. And small companies and traditional companies, we are in the phase to adapt this new technology. And I think we are an example of how we have done this progress through. And my intention is to explain very quick the main steps that we have developed in that process. Our company started in '58, so it's been more than 60 years in the market, and basically we have gone through many different sectors of activity, from automotive, aeronautics, and of course medical. That is the sector that I will devote the time today. But from that picture, you can see that companies need to incorporate technology, and now it's turn of 3D printing. But if you never have adapted any technology, that will be difficult that you adapt 3D printing now. So you have to have a culture of keep adapting new technologies in your lifetime, and as a consequence, you will arrive today, and it will be something natural to adapt 3D printing. That is very important for the evolution of the companies. Basically, we change from the very beginning to the current company now, some figures, to understand that we are a small company. During many years, we have moved our turnover around the 10 million, 12 million euros annual turnover. But what happened in 2006 and what happened in the last 10 years, it's very relevant. And basically, it's due to the incorporation of technology and things related basically to the customization. And 3D printing is part of the customization. Not only, but 3D printing is part of the customization. So we have basically doubled our turnover and basically doubled our number of people working in the company in the last 8-10 years. And my intention is explain how we, what have we done to make it happen, okay? So as I mentioned previously, we started as an industrial activity during many years. We changed our activity, not keeping apart our traditional. We kept working on the traditional activity of doing parts for automotive and aeronautics, but we changed into dental space. When we were in the dental space, basically dental implant producers, we understood that customization of prosthetics was one of the main markets, and we making a step forward in that field. But very quick, we realized that dental was narrow, and we had to expand that to all the medical space. And that is the natural evolution from a traditional company to an advanced technological company working in the medical sector. Okay? Why we do those steps? And this is a mantra in our company. So society and industry are very linked. You cannot understand what happened in the industry if you don't understand what happened in the society. And society cannot work alone without knowing what's happening in the industry. So it's a kind of a circular element. And what are the main changes in the society, or main big changes in the society in the last years? I'm sure I will forget some, very important, but those ones are very important. Clearly, digital world has emerged. This is you know that picture from internet, right? This is the Rome, St. Peter's space, and in only 8 years, you can see how many people are using the mobile technology. So something is going on here, and clearly we have to take that into account. Secondly, our kids, they no longer use books. They use computers, so we have to take that into account. I will not extend on that. You all know that trends, okay? That's another one. What do you prefer? You prefer a Nike boots or Nike shoes that are customized, or the standard ones in the shelf of any store? You need your customized, right? So this is configuring the mind of our users that customization and personalization, and if it's possible digital, it's becoming more and more attractive in our set of minds, okay? And of course, this is what makes the change. So 3D printing enables most of the changes previously explained. So all that is known. But when you come back to your office as a small company of many, many, many conferences explaining big cases, and you see those big companies failing because they didn't incorporate some important changes, digital or 3D printing, those ones were big companies and they are no longer big companies. And you think, my company is small, if they fail, what will happen in my company? And then you have to start that mind reset. And clearly you have to adopt measures. You cannot stay without doing anything. And we decide to do things in the medical field. What I consider new paradigm is because I think those two elements, 3D printing and digital, have changed radically the way our professionals in the medical sector behave. So we cannot understand that everything is stable and only we have a new tool that is 3D printing. That is a wrong image. What changes is the system. And 3D printing is part of that system. And how the system change is what I analyze here. We come from a serial product. The doctors are used to basically order the reference number 2223. And now they order a solution. And this is the key to understand the role of 3D printing. From product, a serial product, to a customized solution. So, and this has impacts in two scenarios. The type of product, but also the process. What type of process do we have previously? You call the ordering center, you ask, we have a stock, we deliver. Easy. Hundreds of years working that way. What do we have now? The doctor is empowered. The doctor starts his power from the very, very beginning. He participates in the order, specification. He participates in the design. And of course, then we have the way to convert the design that the doctor has participated into something physical. But they order and they co-design together with us as a company. And we will see how. And of course, the delivery. And everything can be done digital. There is no need to be physically where the doctor is. We can do that by remote connections and software that allow us to do this digital process. And of course, the delivery. This is not in black, but should be in black. Because if we do something with 3D printing, but we take 1.5 months, it's not worth. So we need to deliver also very quick. So 2 days maximum, hours, this is what we have to challenge. So this is the new process. How it applies to medical, to hospitals, to doctors. Here it comes. Some of my colleagues tend to ask me, when I explain my business, which is my raw material. And when I'm in the medical sector, normally I use the words titanium, whatever. This is not my raw material anymore. And that has to be very, very clear for everyone in the 3D printing industry. Our raw material is the image, is what comes from image. This is what starts the process. No matter which material you will use, of course, is part of the story. But the raw material is our images. So everything starts with a medical image that is basically linked to a DICOM file. This DICOM file has information, but sometimes difficult to visualize. And then we need to convert that into STL with softwares. Materialize, we have been talking before in the previous one. But here we convert and we make a virtual story. When we have the virtual story that we can play in a 3D printing, then our doctors, they realize virtual surgery. They play like if it was in a PlayStation 4 or anything, playing with something virtual, and define what do they need for that patient. When they have this, they make the consent from them, they authorize, they say, this is my design, and then, of course, we make the CAD/CAM process, we print, and we deliver. The hospital is a part that starts here and then returns here. But all that round has to happen in a very, very short term. Our company works 3 shifts, and normally the round of this is 48 hours. That would be, then will be the products, okay? So every single step, image, medical image, you know about this, okay? That's very important, that all the radiologic departments of the hospitals, they can understand the importance of their work. If you have to 3D print a model for pre-chirurgical understanding, and you need the precision, if you take the image at 2 millimeters slides, and then you have to print in 1, you will not be able to. So take into consideration the importance of the image at the very beginning. Secondly, there is additional ways of take images. So also white light scanners, laser scanners, everything has to hybridize, not only tags, more users of scanning. The co-design, we have our engineers that basically are biomedical engineers that talk the same language of the doctors. And they have to be very reactive. And this is the most important element of this, how medical knowledge and engineering knowledge put together in the same place, and they develop solutions. This is very, very relevant. And then, of course, what we are here for is the 3D printing. 3D printing, yes, but. Yes, but. I think 3D printing changes the game, but not only. And this is part of our facilities now, okay? And we use a lot of 3D printing. We have 3D printing from metal, from polyamide, and resins, and all the materials that probably experts from here, they will show you. But this is not my intention. My intention is how we combine technologies. So nowadays, we have to combine technologies. And our solution, I'm not talking about product, I'm talking about the solution, incorporates technology of 3D printing together with milling, high-speed milling, turning, and many others. And the company is worth if the solution provided incorporates all that different technologies. And I think this is something that some actors, they didn't understand. Because they understand that if I buy only a 3D printer and I put it there in my desk, I will be able to bring all the solutions. This is just not true. You need to incorporate many, many other technologies around to have a serious solution. And I think that is important. Well, of course, this is part of our portfolio of technologies with different brands and different technologies around. Okay? It's part of the floor plan. And here, just the type of technology that we are offering currently for that type of solutions. Materials from the most basic resins that started the business to the more advanced combination of titaniums and other metals. Cobalt chrome lately as well. And, of course, the combination of them around. Here is some samples. I think there is some samples also around in the floor, so you can touch it and ask me. The challenge of materials in the medical sector is, I think it will be in the bioprinting area more dramatically, and the bioresorbable materials. That will change basically the rules that currently are affecting the sector. And also, of course, types of CE markings and regulatory affairs. 3D printing is something that is in the gray zone, and nobody is really making a step forward to understand what type of regulations do we need. But there is, when you have a medical product, you need to have certifications. So here, at least where we are based in Barcelona, we have 3 types of regulatory things that we understand we should accomplish. Basically, the one of the ISO 13485 from medical device, the classical EU regulatories. Then we have our facilities. Basically, the facility has to be from your national authority authorized to produce medical device. And then here is for the production of products on the medical side, but by your own. So this is from Catalonia Health Department, and this is very important, which is when you make personalized products. And this is something that is not very, very developed, but you should have as well. Applications. I will go quick because I think I have only a few minutes left, 5 minutes. So I think my next colleague in the stand will talk about dental. I will not talk about dental because I think it's a complementary, but just a few, from model production to surgical guides. So dental is one of the scopes that there is more and more applications. I will not go through because next colleague will talk about this. I will talk about big cases. This is our main source of activity. Basically, oncologic cases, big facial reconstructions, traumatologic defects. This is our main type of processes. You can see some are fixing bones, other are substituting bones. But basically, our scope is for the bone story. We don't print other types of tissues. Basically, bone is our scope. Okay? All that are real cases, basically with Vallebron, with Clinic, and other big hospitals in the area. But now we have placed over 200 different cases like that in the last year and a half. So it's something already proved in that sense. Orbitals, but basically it's head and neck cases. And we print both the model and, of course, the implant to be implanted in the body of the patient. Okay? PIC. This is not printed, this is milled, but it's customized. I always talk about the customization concept. Customization, I mean, if you can 3D print, basically it's okay. But if you don't print it, but you can mill it, at the end, the solution is the customization. And I think that's very, very important. Okay? Orthognathic, condyle, all the ATM area. This is very difficult because we 3D print titanium, that area here, and then we mill here. This is the fossa to protect the bone for destruction, and this is one of the more advanced products that we have with a special treatment, and this is titanium, and it is very, very designed for each patient, okay? Big trauma, this is for big cases that, motorcycle accidents or any type of accident that can be fixed in less than 48 hours together with the surgeons. Kids defects, and here is where the peak takes place, because kids grow, titanium doesn't grow. So if you make an implantation of titanium in the kid, after 1 year, that will tense. So you need to replace and make a different surgery. So then you use materials like PIC that are biocompatible, but they don't integrate with the bone. This is very, very relevant material for the future. And aesthetic defects. These are some for the provisional, and you can see here the shapes that you are able to print with titanium to avoid weight. This is very important. Okay, big cases. Those are real cases. Orthognathic, movement of mandibles up and down to make the right position of the area. Okay, and then of course other areas of medical. This is the spine. This is the classical guide to fix the screws in the spine to avoid touching critical areas. And spine, and of course, this is the cervical area of the spine. Okay? And only to finish, I have 1 minute, to see the different steps when we organize a case, which is the flow. I make it theoretical. Now you will see practical. Case 1, this is one case where you can see a big defect in that mandible area. This is a cancer. This is an oncologic area. And then we, together with the doctor, what we make is segmentate and then define where do we have to cut. And when we decide we cut here, we provoke and we design a guide. And that will be the guide that will be placed into the patient and then will help for the right evolution. We go to the fibula. We take 2 fragments of the fibula that will substitute the mandible. And how do I do it correctly? Well, I use, again, a guide. And with the guide, I will use the angles when they are placed in the mandible to reconstruct exactly the shape of the previous mandible. I will go here. You can see the 2. We come from dental implants, so we understand that we can even place the dental implants in the mandible and bring it up with the right position. And then we fix everything with a plate of titanium 3D printed. Okay? So those are the products. But those are not important. The important is the service around and the package that we offer to solve that case. And this is very relevant. Okay? This is the right case. I think you can see it in the area there. And I think the case 2, I will go very, very quick because I'm out of the time. This is again the same situation where there is no mandible. We develop the mandible, titanium. We fix that with the right screws. We understand the phase of the patient, how it will change. And here is the product when finished. 2 lines for the discussion later, only 2 points, that's all. This is what happened with the color and the shapes and the textures. This is a challenge for the 3D printing, and of course, the bioprinting that will be discussed later on. Okay? Thank you for your time. Thank you.
Thank you very much. I'm so sorry to interrupt you. Please give that to Dr. Seeberger.
Yes.